Hi, my name is Elric Aguado and this is COE186P activity number 4 under section A01, and this activity is entitled temperature sensor. So this part 1 we're gonna use temperature sensor, which is LM35, this one, and then we're gonna need a breadboard, some jumper cables, and of course the Arduino Uno. So the first thing we should know is that when the flat surface of the LM35, uh, when you're facing the flat surface of the LM35, the right side is the ground, the middle is the for the analog, and this analog signal, and then this left side is for the 5 volts. So first we should connect this to the Arduino. So here, so I connected the analog signal to A0. So let's get started by coding. The thing that I will do is to define the sensor, which is will be put on A0, and float for the input temperature conversion to Celsius, and temperature conversion to Fahrenheit. So let's put a serial that begin to 9600 for it to be shown in the serial monitor, and then here in the void loop, let's start putting input is equal to the analog read of the sensor, which is connected to the analog 0, and then temperature underscore C is equal to the input multiplied by 51024. So here, let's put the temperature for the Fahrenheit. Temp underscore F is equal to 9 multiplied to the temperature underscore C divided by 5, and then add 32. So serial dot print for the input value, then serial dot print, of course, the input and then serial that print ln, so that it will go to the other line, and for the serial that print for the temperature in Celsius, serial that print temp score C, serial that print degree Celsius. So wait, degree Celsius, and then serial that print ln. So let's copy this for the Fahrenheit. So Fahrenheit, temp underscore F, and then of course let's put the delay. Let's say 1 second. Okay. So let's check and verify. Let's now upload this to our Arduino Uno. So it's done uploading. So we can now check here in the serial monitor. So it says here that the 24 seconds, 24 degrees Celsius and 77 degrees Fahrenheit. So that's it for part 2. So for the part 2 of this activity, we're gonna use a buzzer. So this buzzer have positive and negative side. So we're gonna connect this to the breadboard. Oh, it's a little bit hard. And then connect the positive side. Connect it to the digital pin. I chose pin number 8, and then connect the negative side to the ground. So ground connection. Okay. Yeah. All right. So now let's recycle the code that we did for the first part. So here we will define the buzzer. So busy, we put it at pin number 8, and then pin mode. Let's define the pin mode that sensor is the input, and the pin mode buzz is the output, like that. Um, so the conversion is just the same as the first one, but we will have an if statement here. So if the temperature is, let's say, greater than or equal to, let's say, 26 degrees Celsius. So degrees Celsius, temp underscore C, I mean, underscore C, degrees Celsius. Let's say that the digital write or the buzzer of the buzzer will be high for with a delay of, let's say, 200 milliseconds, and then digital write buzzer low delay 50 milliseconds. So else else digital write buzzer slow. That only means that the buzzer will not be turned on if the temperature is less than 26 degrees Celsius. Yeah, and that's it. Let's check if there are no errors in this uh, code. So done compiling, let's upload it. Uploading, and yeah, it's done uploading. So now let's check here in the comps. 25, it's not that hot, so it's the buzzer is not, and then you see that there's a 26 degree and the buzzer turned on. So yeah, that's it for this activity. Thank you.